Let's talk about atomic radius. So this, in my opinion, is the most important periodic trend, because if you understand this, as well as my last few lessons like atomic orbitals, electron configurations, and orbital diagrams, you can kind of figure out the rest of the periodic trends just from understanding this concept, okay? And the concepts that I'm going to talk about in this video. So let's get to the lesson. So the idea is we're talking about atomic radius, and if we look at an atom, we have the nucleus where the protons and neutrons are, right? So I'm just going to draw a little two-dimensional sphere here, our circle, with a couple positives in there, so there's some protons in it. And then the electrons exist in the orbitals, right? So it's like a cloud of the probability where the electrons exist, blah, 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 wave functions. We don't have to go too far into it. The point is the electrons buzz around in the cloud. And so if we talk about the atomic radius, we're going from the center of the atom to the outside, right? And that's our radius. Now, if we look at a diameter, that's just like twice the radius, right? So if we just went all the way through, what are we measuring? We're just measuring the outer reaches of the electron cloud, right? Of the largest shell of electrons. And so the atomic radius, if we're changing like the number of neutrons in the nucleus, that's not really going to do anything to this electron cloud, right? So just want to know, what are we measuring when we talk about atomic radius? It's the same thing as saying like atomic size. If you have a bigger radius, you have a bigger atom, right? That's all we're doing here. So if we look at the periodic table, we want to figure out when we go like down a group or to the right or to the left across a period, which way do the atoms get bigger and smaller? So let's start with the easy one. If we go down a group, we are adding protons and neutrons to the nucleus of each element and more electrons in more energy levels. And so it's kind of obvious that the atoms are going to get larger as we go down a group, right? So if we look at period one over here, group one rather, hydrogen is number one, meaning it has one proton, and if it's neutral, it has one electron, right? And we go all the way down to francium, and that has 87 protons, a bunch of neutrons, and then 87 electrons. And so it just seems very intuitive. You got more stuff, it's going to be bigger, right? Now, let's talk about that in a little more depth, though. So if you saw my previous videos that I mentioned, I talked about the energy levels of electrons, principal energy levels, and we also just call them electron shells, right? And so as we go down a group, each period is adding a new principal energy level of electrons, a new electron shell, right? So it might look like this on a certain shell, and then we go down an element, and then we just added a new shell of electrons on the outside, right? Over here, this is where our electrons are buzzing around. And so it's quite obvious that we're going to have a larger atom as we go down a group. Okay. So now let's talk about as we go to the right. As we go to the right across a period, the atomic numbers get bigger again, right? So if we're looking at like period 4, we have potassium as number 19, and we go all the way to the right to 36 as krypton. So again, we're adding more protons and neutrons to the nucleus, and we are adding more electrons as well. And so it may seem intuitive to think that the atoms are going to get larger as we add more stuff to them, but that's actually not correct. So let's figure out why. So the thing is, as I mentioned, as we go down a group, we are adding more principal energy levels, more electron shells, right? Boom, we jump another shell, and that's a much larger atom. As we go to the right, though, we are not adding new principal energy levels. We're just adding more protons and typically more neutrons to the nucleus and more electrons to the outermost shell that we already have. Remember, we call the outermost shell the valence shell. So we're just kind of crowding the valence shell and adding more protons to the nucleus. So we're not adding like this big extra layer of electrons. We're just filling up what we already have. Now, as we add protons to the nucleus, we are increasing the nuclear charge. That's just what's the charge of the nucleus, right? So basically, how many protons do you have in the nucleus? That's your nuclear charge. And then there is a shielding effect between the electrons in the valence shell and the electrons in between. So sometimes we refer to the effective nuclear charge, but just to keep things simple. As we go to the right, we're adding more protons to the nucleus. We're not adding new shells of electrons. And so we're increasing the attraction that the nucleus has on the electrons. So it's kind of squeezing them in tighter and tighter every time we add another proton to the nucleus. Yes, we are adding more electrons to the valence shell as well, but we're not adding new shells. So basically what's happening is the more highly charged nucleus is pulling in that valence shell of electrons as we go to the right, in general. Of course, there's always some exceptions. Things get a little funky down in the middle of the table there, but in general, the trend is that the atoms actually get smaller as we go to the right because of the increased nuclear charge. And remember that, that's a very typical multiple choice or fill in the blank type of question you might see. Like, why do they get smaller as they go to the right? Because of the increased nuclear charge, all right? And then as we get to the noble gas, we add one more proton and electron, and that brings us to the group 1 of the period below it, right? So we were in period 4, and now we're in period 5. And so now we added principal energy level, or shell 5. And so now we got smaller as you went to the right over to krypton, and I'm just using period 4 as an example. We get smaller as we go to the right towards the noble gas, and then we had one more proton and electron, and boom, we had a whole new shell of electrons onto it, and now we get a much larger atom here, and we have that larger atomic radius, and then we just start the whole process over again. As we add more protons and we go to the right, we increase the nuclear charge, which pulls everything tighter. Again, this is in general. Just remember, if you ever look at like an actual chart of atomic radii versus group number, there's some funny things that happen in the middle that really in a general chemistry course you're not asked about. You just need to know the general trend. We get larger as we go down a group, and we get smaller to the right. And so I like to summarize it as just phrasing, the elements in general get larger down and to the left. So down and to the left are the larger atomic radius. So guys, if this helped, please give a like, follow, share this with someone that may need help, save it so you can review it again later. And if you'd like to go above and beyond, go ahead and check me out over here, and you can patronize me. That helps me to keep making these videos for free. So thanks guys, and I'll see you in the next one.